Hello, welcome to another video on sagemath. In this video we are going to see how sagemath system can be used to find the inverse of a function if it exists. We denote the inverse of the function fx as f inverse of x. To see the more details of finding the inverse, let's discuss an example. Consider this example. Determine if the function fx equals 2x square minus 2x plus 1 has an inverse on the domain minus infinity to plus infinity. If it exists, then find the inverse. And the solution of the outline of the solution is here given. First we know that you can note that f0 for the given function f of 0 equals f of 1 equals 1. Thus, if f is not thus here the given function f is not 1 to 1. So we can also plot the graph of f and note that it fails the horizontal line test, since it is not increasing on its domain. So you can see that when we test that horizontal line, when we apply the horizontal line test, you can see that the function does not satisfy the horizontal line test. It's also not 1 to 1. So here what we are going to do is we restrict the given function, the given curve in the interval in the interval which is on the right side of the number x equal to 1. Here you can see we consider only that very limited interval from 1 to 5, x 1 less than or equal to x less than or equal to 5. Okay, we now come to the actual steps steps of implementing the problem, steps for finding the problem. See, the first we define the function fx, the given function fx equals 2 into x raised x cap, x raised to 2 minus 2 into x plus 1. Then we can see a plot of that the curve using that plot command. So one by one we can demonstrate that. G equal to plot. Okay, then for taking a plot, type again G, and then you can take the. You can wait for getting the output. Yeah. Thus we have obtained that output, the plot of the curve. That curve is fx equals 2 into x square minus 2 into x minus 2x plus 1. But for this function has two values for every for the values of y. For a particular value of y, when we take the value of y from x equal to 1, specifically if you take this value, then you can see that when we draw a line horizontal to when we draw a horizontal line, or when we draw a line parallel to the x-axis, you can see that the curve meets with that line at 2 points. So it doesn't satisfy, the given curve does not satisfy. We can see from the shape, from the using the nature, using the shape of that curve, we can see that it does not it cannot be used to define the function as it is given here As such, you cannot use it to define that function. What to define? The inverse of the function. Okay. Then what we do, we now restrict our function to the interval, to an interval which lies on the right side of x equal to 1. So we restrict our attention to, to overcome this, we restrict our attention to the interval, the closed interval 1 to plus infinity, 1 to infinity. But you know, here we cannot see that, we cannot see the plot for all x which is greater than 5, because we have limited our the region of plot. We have limited by saying that we want the plot between x equal to 1 and 5. Okay, so but in general we consider the interval from 1 to infinity for defining that function, and then we draw the plot, repeat it, the same plot function for plot command, we repeat to obtain the output. And when you take the output, you can see that the new restricted function, you can see the plot of the new restricted function. Okay, then we are now ready to define the inverse of the function. Now to find the inverse of the restricted domain, you know, we here what we do, what we did, we restrict our the domain of the function is here restricted. After restricting the domain of the function, we then define y equal to f inverse of x. We are going to define the function y equal to f inverse x. Then we have fy equal to x. Okay, then we assume that this is the procedure. When now we assume y equal to f inverse x, and therefore based on this assumption you can say that fy equal to x, fy equal to x, and thus we solve our we then what we do then, we then solve for y. We want the values of y, so we try to solve the expression for y. After writing it fy equal to x, after writing fy equal to x, then we solve it for y. Then we solve the equation fy equal to x for obtaining the value of y. So we define two variables to avoid the error of not defining the variable. We define the variables x and y as two variables. Okay, that you can see. Okay, so here using that command we define the variables, but you know, x comma y, I just type it again because we want that in quotation mark correctly, we want that. Okay, it is showing yeah, that quotation mark is repeated there. Okay, now let's try. Okay, yeah, we have defined two variables, and this is the step. Using this step we define two variables. And then you can write, you can use this command solve sol equal to, so sol is the variable actually, sol solution. Okay, we define next we define a variable solution sol to store the value of y, which we are going to determine using sagemath system. So so we write the command sol, the variable, equal to that variable. First we name that variable, and then the location of the variable will be assigned by the solution of the expression f of y equal to x. We know that previously we have defined that we have explained that we are going to solve the function f of y equal to x on y for obtaining the values of y. So when we use the command solve, when we use the command solve here for y, then you are going to store the value y at the variable y. Okay, that can be done. Then now you can verify that using just by copying that and then okay, if you want to take the output, type the variable. If you want to display the content of the variable, here is SOL, so content of the variable. Okay, and there is no error. It shows that there is no error. We have obtained the value of y equal to minus 1 by 2 into square root of 2x minus 1 plus 1 by 2, and the second y value equal to half of square root of 2x minus 1 plus 1 by 2. Okay, yeah, this is that. You can see that here also we have that the same quantities obtained. Then it's correct. Our computation is correct. Okay. So this is the function. The inverse of the inverse function is f inverse of x equal to half of 1 plus root of 2x minus 1. Note that Sage gives, but you know, here, since this is the inverse function, here Sage gives two solutions, two values for y. Only the second one is valid because it is in this range 1 to infinity. But you know, you can you know that we have restricted our attention to the domain 1 to infinity. So since 1 to infinity is the valid domain of our discussion, we need to consider the obtained value y value. Even though there are two values of y are obtained here, we need not consider the other value. Only we need to consider only that value which is valid, which exists in the interval 1 to infinity. Therefore, you can from 1 to infinity, which value exists? And that's the question now. So to extract the solution on the above output to extract this the solution from the above output, we use the syntax below, and which is given below, and denote the inverse function of Sage, inverse function by gx. So we shall denote the inverse function by gx. So we want to extract that value which is valid in the interval 1 to plus infinity, 1 plus infinity. So for that you can use the command for extracting that. You can, and you will we will denote that the inverse function by gx. Gx will stand for the inverse function, and you can see that extracting step or finding the final solution step. And then you can type, if you want to take the output, then you can type gx again, and okay, after that you can just enter, and we have obtained that we have obtained half of square root of 2x minus 1 plus 1 by 2 as the value, as the function stored at gx. So this is that this is the inverse of the function. Next, we want the final step. We are going to the final step of this problem, where we will plot the function inverse. And you know, this function g now satisfies the condition g of fx equal to x. Okay, this will be then correct. And in fx, you can, if you substitute in g the value instead of x, or the price of x, if you substitute fx, then you are going to get x. Now using the command g of fx equals g of fx, okay, then we can use the simplify full to get the expression completely simplified. Yeah, and now one can okay. Okay, there. This is the final step. There, in that final step, we are going to plot. Okay, as I just mentioned, we use this command, this plot command. But you know, in the plot will be stored as a variable h. At the place of h, so we use the new variable h to store that plot, to create and store the plot. Okay, therefore let's copy that and paste it here. Then now after running this statement, then you can see that the plot will be stored at h, and if you want to take that the plot, then you can just type h and take the output. Okay, thus you can see this this small figure that stands for the function, the newly obtained function, that is the inverse, as well as the given function. So this function and this thing, this plot contains both. This is the actual function, the given function, and the inverse of the function. You can see the inverse of the function is also plotted here. Thus the single figure contains both functions, the given function and the inverse of the function. Okay, and by this we come to the end of that the discussion of the problem in which we explain how to find the inverse of a given function in a given in a particular domain. Okay, thank you.